Yeah, so hello again. I haven't got special presentation for the test because most of the speakers starting from Luca and Rainer yesterday and Tilo Hollehausen, they spoke already about all these issues, and I totally agree with them because there was a LAK, our glider from LAK company, which was actually remade to the FES by Luca, because Luca was our dealer in Slovenia, and as a model builder he just used the techniques from models, and yeah. So just there are a few hints which I wanted to mention. When I demonstrated the first LAK 17B in Hungary, Tilo Hollehausen said, "You will never see such propeller on a German glider." It's flying drag, but actually it isn't. After a few years, Tilo said, "Yeah, I really like flying the FES." So yeah, so LAK 17B was the first glider to which we certified with EASA as a sustainer. It took us 4 years because EASA was making rules working with us. So now when we have new systems, they are still making more strict rules, and everybody knows about that. Yeah, so the next idea was to get a self-launching FES, and we did it on the mini LAK because this new 13.5 meters class gliders appeared, and so for the World Championships we built the first prototype without engine, and then we saw that we had enough space for a high undercarriage, so we installed the FES engine and tested it, and it could easily self-launch, and so according to our engineers, the angle of attack while on the ground was by 3 degrees below stall angle, and so it is safe, and if you depart from takeoff from 2 points, it starts accelerating so fast that there are no safety issues. The next step was, because we did overcome these questions about propeller ground clearance, then we said why shouldn't we test it on the 17B, and so we found a way to make high undercarriage and install the same engine with higher. We increased RPM, and Luca designed 16 cell battery packs. So yeah, it does take off. Of course, initially we think it's good without water ballast, because our way of thinking is that you need full wing load, high wing loads when you fly competition, and if you go to competition you always have tow planes, and you don't need to self-launch actually, because the organization does it for you, and you save your energy for flying back instead of outlanding. From my experience, I fly FES gliders for 13 years since we installed the FES motor in the prototype. I flew average 3 competition every year, so 30, maybe 35 competition during this time, and I didn't reach home just 3 times. 2 times I landed in airports where I could use air tow, so not wasting time, not undertaking any risk. And once I had time to fly with the motor, looking for a place to land in southern Poland during European Championships in Stalowa Wola, where there were lots of gardens, and it was really difficult to find an outlanding place, but it was good to fly with the motor at low altitude and just to find a safe place to land. Yeah, and we have a certified LAK with the turbo engine, starting from the LAK 17A and B. So it's, to say the truth, the first 17B first was also installed into the turbo prepared engine because it was big box for battery packs, and for the controller everything was in this big box, and just 2 wires going to the motor. Why don't we install this lifting motor? The reason is the complexity, and then you have more complex system. You have much more possibilities for the failure, and in the first we have very few components which might fail, like a switch indicating that your canopy is closed. But if something fails, or you have some higher temperatures, all these warnings, it's easy to bypass them, just pressing the button, and you may use even the how to say, below limits. You may use your batteries, you get warnings, you may get shouting, somebody asking stop the motor. But if you are in the position where you need to fly away from the forest or from the lake or from the dangerous area, you just use your battery to the flat, replace your battery, and then if it's damaged, but you have saved your life, your glider. So this is our philosophy. For the safety reason, of course, electricity is faster. I'm flying gliders since '74, so all my life, and I did fly a lot of turbo. I only use turbo during test flights in the factory, but as soon as it comes to competition, I always outlanded with this hanging air brake, because I always fly in competition. You are fighting to the end, and no time to start the motor. So the FES is a totally different system, and safe, and especially for young pilots, for training processes like final glide procedures, just getting trust in your instrument indications, and because everything is when it gets everything to low altitude, people start thinking different way, because you are always want to live, and maybe you turn around and land. But with the FES, especially with this finish ring, you may go to the ground and then start your engine, make a safe procedure. And another issue is that you get full power within with the speed of light. Let's say when you get low, you switch on the main switch, and you are simply always, you see that the controller is ready, all greens, and you just turn the button, and you get full power immediately, and about 2.5 to 3 meters climb with full battery. So for another issue is, as Tilo said yesterday, even with 13.5 meters, you can fly very long tasks, little bit helping with the engine, increasing your gliding ratio. I got this example from a Polish customer, Christoph, who is mostly flying 18-meter class gliders. He just got one flight in the mini LAK. He took off in the morning at Leszno, where they had over 100 gliders waiting in the line to be loaded. It was the Polish Nationals or Leszno Cup. So they were told over 3 hours just to get into the air, waiting for a start line opening, and they flew something like 300 or 400 kilometers. And in the mini LAK, he took off at 10 o'clock, and his first flight he did 800 kilometers. So without using engine, of course, he finished the task. But it means he used the whole day for flying. And another concept is that small glider is for maybe good for non-competition pilots who can handle it on his own, because one wing weighs only 40 kilograms, so easy to rig. The rig is, of course you can use one-man rigging equipment, but if you have one helper, that's enough. You can operate it, take off from the wing on the asphalt, and that's very easy. For the 18-meter class glider, we are also, as I said, if you fly competition, you always have a co-pilot, but if you are alone on the field, you just need, on the asphalt, you can also take off without anybody to hold your wing, just from the wing, and so you take off from the grass and from the asphalt. What I also tested is the LAK 17. We've got 18 and 15 meter version. So 15 meter version is pretty high wing load, maybe 47 with my weight. So ground run is a bit longer, but anyway, you take off and you can fly. We also have tested the 21 meters wingspan as an open class glider, but the main issue is we got a good high glide ratio, but the problem is that we had not enough space for water, and the wings are very narrow, and we cannot get high wind loadings in the open class, and the glider is just for fun flying, but it is not good for competition. We are developing new winglets at the moment, so maybe we get some better climb in thermals, and also thinking about making a plan and engineering to get extra batteries in the wings. So if we could install additional 15650 battery packs in the wings, we could triple the endurance. So it might be good for, of course it will take off without any problems, and the glider would be good for touring. Talking about cooperation with other manufacturers, all other manufacturers who use FES systems, we shared our experimental materials with them about the fast propellers, which Luka developed the shape, and we've done the technological layouts of the blades, because initially some of them were cracking, because it's quite interesting shape of the blade, and it wants to get straight. And then there were some cracks, but after we made the examination of the cracks, it looks most of them were just cracks in the paint, and yeah. So at the moment, that's all, and we already spoke to many people, and I answered their questions. If you have any more questions, you are welcome. And yeah, just talking about charging airplanes in different airfields, of course it would be good to have some standard. Our chargers are not they are light, but big enough to carry them in the glider. If you travel with the electric glider, you should it might be good to just to carry your credit card and forget about carrying chargers and all other equipment. It should be very good. It might be good to have them standard, and that you may charge your batteries in an airfield. That it would be a good idea, but I don't know how we come to such standardization. One other thing what I want to say, these are pictures where we demonstrate low flying. So that would be with the FES, it would be pretty safe for young pilots to train finding thermals in low altitudes. What it might be difficult to achieve with a pure glider, because it's a lot of risk, and so to overcome your psychology, because our sports, as we know, it is psychology. It's glider performance is very important, but psychology is probably your brain is the main thing which makes you a winner. And that's all what I wanted to say. I wish you safe flying. Good luck. We have now our waiting list is less than 2 years.
What is the price of the mini LAK? Can you tell us that?
Mini LAK with the motor, empty glider with the motor and battery packs is 100,000.
Plus VAT, yeah.
Plus VAT, yeah. Plus instruments, it's upon your choice.
Yeah.
The trainer.
Okay, questions?
The propeller blades, are they fiberglass or carbon?
Combined.
Combined.
Mostly it's carbon, but we combine it with the glass.
Okay. I have known Vytas since the first time we met was in Finland at the European Gliding Championships in 1988, and we met in the middle of a lake after the sauna.
This is my pleasure. I study Swedish now. Good.